Hello and welcome to Learn Data. It's great to have you on this channel. I hope you are all doing well. I'm Nilesh, and in this video, we'll look at an overview of what is machine learning. I'll give you an intuition of what is supervised versus unsupervised learning. Then we'll look at some of the terminologies that are commonly used in this area, which is such as train, test, validate, parameters, clusters. What do they mean? And I'll introduce you to a new computational resource, Google Collabority. If you do not already know, we'll continue to use Jupyter Notebook, but this is just in case if the training sessions become more intense. Then if you need more hardware, that could be one option. And finally, I'll introduce you to Scikit-learn, and also mention like a command that you could use to install Scikit-learn if it's not automatically installed with Anaconda, and look at some of the frequently asked questions just to clarify some myths or doubts while using Scikit-learn. So, what is machine learning? So, this is the Wikipedia definition from machine learning, and what I understand from this is that you're basically writing a code that teaches a computer to learn certain parameters from the data to create a model, and then the with that trained model, when you feed in new data, it can predict outcomes that you ask it to. So let's say without machine learning, what you could do also is give the computer a set of instructions like a recipe in detail, and then the computer can use that recipe to give the predictions that you're looking for. However, with machine learning, what you can bypass that and let the computer do the job of writing the recipe by itself. So what you do then is give the computer data and a model. Then the task of finding the optimal parameters or weights for the model is done by the computer, and it will give you a ready-made model that you can use on new data to get the predictions. If you look at this flowchart, you have the data that comes in, at least in case of supervised learning. You'll have the features X and target Y. So what I mean by features is, let's say if you're trying to predict rainfall, then the geographical location could be one feature, time of year could be another feature, and the target could be the amount of rainfall in that particular location. So once you make that data available to the computer, then based on the code, it can go ahead and learn the parameters or weights that are for the variables in that particular model, and that does it's an iterative process. So once that is done, you'll have a trained model ready. Now that trained model can be used on a new data set to do predictions. Let's say if you have predicted if you have trained the model on certain location cities in a country, and if there is a new city that comes in which has similar features, then you could get rainfall for that particular new location as well. So here we have another example. We have chicken and an egg example for supervised learning. Imagine there is a poultry farm, and there are eggs that have been collected. Now each egg is weighed in grams, and that's what we see here in the left hand column. And on the right hand side, we have the egg size. So this would be a label. So each egg is labeled based on the egg size. So if its weight is 73 grams, then it is labeled as very large, or if it's 43 grams, then it's labeled as small. So based on these weights, we have the labels, and then that can be used by the computer to train. So as we saw in the previous flowchart, this would be X and this would be Y. Now moving on, let's look at another example where if we are trying to find what is the category or label for a new egg that we just have found, and let's say if its weight is 55 grams, what is its category? So then you'll use the trained model, and that based on that you'll get an output that the category would be medium. In case of unsupervised learning, what we have is a data set without any labels, so there are no labels. And what we have in this case is a data set where we have only the weights of the eggs, as you can see, 73, 63, etc. Now what we can do here is we can ask a question. Are there any groups of weights? Are there any groups, say 40 to 50, 50 to 60, etc., in the eggs that we have, egg weights that we have measured? And yes, so that's a possibility that we can work with. So the computer can be trained on such a data set using clustering algorithms, and then once the model is ready, we can go ahead and find these groups. As you can see here in different colors, we have one group that's right here, then second, third group, and then we finally have the four groups. So based on the size, based on the weight, we can now separate them into different groups. So we can then go ahead and label them, give these different clusters names. For example, small, medium, large, and extra large, and then use them accordingly. So that's one example of unsupervised learning. So the main difference is labels with supervised learning and no labels with unsupervised learning. Now moving on, let's look at some of the terminologies that you'll commonly hear in machine learning. The very first one that we have here is a train, cross-validation, and test data set. So usually what would happen is when you have a data set, you'll need to split it into either train, validation, and test set, with percentages that I've shown here is 60, 20, and 20. This can vary. So let's say if you have 100 rows that are there, then you have 60 rows assigned for training, you have 20 rows assigned for validation, and then 20 rows assigned for test. So while training, the computer would not see any of these data sets. So once the model is trained, it can then be run on this unseen cross-validation set to find out how good the predictions are. And based on that, the parameters can be adjusted. And once the final trained model is ready, it can be tested on a new unseen data set, which is a test set. And this is supposed to resemble the real world data set that on which this trained model should work correctly. So it's important that the predictions on the test set are good after a model is trained. Moving on, let's look at another terminology, which is train. As we saw, what training is we have it's a iterative process as shown here, where the computer learns the model values for the model parameters, it learns the weights, and once these optimal values are found, then we have a trained model ready. So that's what the train means. Moving on, let's look at what is a feature. So a feature, as we have seen before, is a set of data that helps explain how the target is related to with the data. So here we have the egg weight. That's one feature, and that tells what egg size it is based on the weight in grams. Now we could also go ahead and add other features here. Let's say, for example, it could be age of the chicken, that could be one parameter, or the color of the egg, that could be another one, or the feed that is given to the chicken does that affect the weight? So that could be another feature as well. So all these features together can be used by the computer during the training time to find the values for the parameters to get a final trained model. So a feature is uh, a set of data. These are all independent, so they are not dependent on each other, uh, and the target is dependent on those features. Now let's look at what is clustering in unsupervised learning. So in unsupervised learning, as we saw, there are no labels. As we can see, if in this particular picture here, we do not know what groups each of these dots belong to. So we can train a model that can find these clusters. So now we see that there are these four clusters, and that's the job of unsupervised learning algorithms. They'll find the groups or clusters, and then you can use these groups or clusters for a specific purpose. For example, if you are in a marketing team and you're trying to segment customers, then based on the data that's available, you could find these groups of people who have similar buying habits, and then those could be targeted for maybe discounts or those types of products that they could purchase in the market. Moving on, there is another example. So here we looked at the egg weights. Now let's look at another example where we have the egg weight and the age of the chicken. So we can clearly see there are two groups, but these are unlabeled. So for computer, when we run the clustering algorithm, it will try to find these two clusters, and once it does, uh, here they are shown in orange and green. So now these are two clusters, this group 1 and we have group 2 that is found. So these could be useful. Let's say for example, the group 1 could be good for making omelets, and these types of eggs could be making good for making scrambled eggs. So that's one example where unlabeled data can be grouped using clustering algorithms. This is the unsupervised learning approach in machine learning. Now let's look at supervised learning or classification. Uh, as shown in the previous graph, here we already have the data points labeled. We have the group 1 and group 2 already labeled and colored here. So what happens if we get a new data point? So let's say if we get this new data point, does this belong to this group or does this belong to this group? Now to find that, we can use a classification algorithm that will assign that could work in a way where it will separate these two groups from each other, and then because this particular data point is closer to the green objects, maybe it will assign it to this group. So and then the label for this group would become group 2. So that's one example where uh, classification algorithms can be used in supervised learning. Now let's look at what is scale, normalize, or feature scaling. If we look at this table on the right hand side, we have these two columns, egg weight and chicken age. Now if we try to compare 73 with 1.3, 73 is much larger number than 1.3, and this is not acceptable in some of the algorithms, because this discrepancy or these the magnitude of difference can make the model think that these are more important parameters than this one. So but that's not actually the case. So what the general practice is that we can convert these or scale these uh, in a way that they are in a similar range of order of magnitude as shown here on the right hand side. So these are normalized. So one way could be we can subtract each of those values from the mean of those and then divide them by standard deviation. So then we can get this value. Now these values are, they look pretty close. There's not much difference between those two. So that is what is called scaling or feature scaling. Now let's look at fitting. So by fitting, you probably heard about curve fitting. It is a similar concept. What we are trying to say here is if we have a new data point, it needs to be assigned to one of these two groups, either this group or this group, and then we can train a model that can find the two groups and find this particular data point if it's closer to that group or this group and assign it to the appropriate group. However, in this case, as you can see, we drew this line which is a pretty straight line, but that may not always be the case when we are training a model. So for example, in case of overfitting, what the computer could do is fit this group too closely. So what it's trying to group through, it's trying to find the margin so close that it's overfitting. So this particular point, although we know that it's closer to the green, it could get by mistake assigned to the other group, and that's the kind of errors that could be due to overfitting, and this needs to be avoided, and we'll talk about that in future videos. So similar to overfitting, there is also a concept of underfitting. So if we look at this particular figure, these two groups are separated, but as you can see, the line that separates these is horizontal. So what that means is these data points right here, they would belong to the group which is green in color, and that may not be the case. It looks like this line could have been the correct way to separate those two groups, but if it's underfitting, then we have this problem, and therefore again this point that we have here could be assigned to this group by that could be error. So we'll look at how these overfitting and underfitting can be avoided in future videos. Here I just wanted to give you an intuition of what those words mean. Now let's look at another word which is called loss. What loss means is how different or how far away from the predicted values are the actual values. So here we can see this predicted line, and these values are far away from the actual predicted value shown here in the black dots. So because that's the case, the loss value of the loss, it's just a number, the value of the loss would be high. Now in case we want to reduce the loss, so here we have another predicted line. In this case the line goes through like this, and it seems that the values for loss have reduced, so the difference between the actual and predicted values is low, and thus the loss is minimized, and that is a good thing. So in machine learning, you'll often hear this word minimizing the loss, and there would be something called as a loss function. We'll look at those also in detail in future videos. So what we are trying to do is minimize the difference between the predicted and actual values, so that when we use that particular model in a new unseen data set, we get values, predicted values that are more realistic. Moving on, now let's look at another terminology, binary. I'm sure you've probably heard of this. What here it means is that there are two outcomes. In this case, let's say if we are looking at the target here, if we have these features, chicken weight and chicken age, based on this, is that particular type of egg sold or not sold. So if it is sold, then we have value of 1. If it is not sold, then we have value of 0. Thus the uh, it's like a binary problem, 1 or 0. It's just have two possible outcomes there. Now after that, let's look at what is a label. Label is what we had here. So we had 0, 1. So these are all labels that we have given if the egg gets sold or if it does not get sold. In addition, the labels could be any other type. So for example, if we are looking at the quality of the eggs, if we say quality, then the labels could be, this could be grade A, this could be grade AA, this could be grade B, or this could be grade C. So these again could be labels that can be used as a target while training machine learning algorithms. And this would then be a supervised problem. So this would be a supervised learning algorithm. Now let's look at difference between classification and regression. As you can see here, in regression, what we are trying to predict are continuous. We are trying to predict continuous variables. So continuous variables, and in classification we are trying to predict discrete. So as you can see here in this particular chart, we have the egg weights and we have chicken age. So based on the weight of an egg, we can go ahead and predict the age of the chicken right here. On the right hand side, we have this data where we do have the egg weights and chicken age, but then what we are trying to do here is group the data into two clusters. We have one group that is right here, which is group 1, and then we have the second group which is right here, which is group 2, and then we could label these as group 1 and group 2, and these could be for used for further analysis, let's say for what could be the uh, protein content of these eggs versus these eggs, etc. So that's the difference between classification and regression. You're trying to predict continuous data versus discrete data. Now moving on, let's look at what are the computational resources that we have available apart from Google, apart from Jupyter Notebook. So here I've put Google Collaboratory, and this is really helpful. This is the site, you definitely want to check it out. You'll need a email account, so Gmail account would work for this. So the reason why this is helpful is for two reasons. One, you will have a CPU and you'll have a GPU. Although we won't be using GPU for Scikit-learn, we may use it for some other algorithms that if we run them in the series, we may need this. So, and if the programs are intensive for training, if there is a lot of data, then this particular CPU could be helpful. If the training takes a longer time on your computer, then maybe running it on cloud on Google Colab could help. If we look at how the interface looks, this is Google Colab notebook, and here if we go ahead and click on new notebook. So if you click on this, then you can go ahead and open it, and it looks like this. So as you can see, similar to the Jupyter notebook here on the right hand side, here the method is same. You have each of these cells, and each cell has a play button, so you can run that to run the code within this particular cell. And we have similar interface here in Jupyter notebook. If we get into Google Colab, I'll definitely mention how to use it. For now, this was just to introduce you to this new resource, that even if your computer does not have a powerful GPU or a powerful CPU, this would definitely help you out in those situations. Now let's look at Scikit-learn. This is already installed in the Anaconda package that you may have already installed if you are following the beginner series video. If not, then I'm on Mac, and the pip install scikit-learn, this command would work. If you need help with installing scikit-learn, then I'd suggest you visit the link shown here, which takes you to the scikit-learn website, and it has a detailed set of instructions to install it on either Ubuntu or Windows. Moving on, now let's look at what is Scikit-learn. So Scikit-learn is open source software, as you probably already know, for machine learning, and it's built on NumPy, SciPy, and Matplotlib. So from the beginner series, you'll remember that we have talked a lot about arrays, and that's going to be really important here when we are working with scikit-learn. So, or any machine learning algorithm for that matter. So we need to know how arrays work, how the array manipulation works, and then of course we have matplotlib for creating different types of plots. So that's also really helpful in this case. Now with scikit-learn, these are different frequently asked questions, and I just wanted to go through some of these because these can clear some of the doubts that you may have before we get started into this library. So the name, of course, is scikit-learn, as you've seen. Now it does not directly work with pandas data frame, so that may be a surprise, but it we need to convert that to numpy arrays. So the data frames, we have seen that in the beginner series. So once we have the finalized data frame, we can easily convert them into arrays, and then those arrays can be used as an input to these models. So that's one important point to remember. In addition to that, if we look at this, where we see that GPU support is not there for scikit-learn. So if you're trying to run scikit-learn algorithms, you want to remember that it cannot use a GPU. So that's very important. However, although it cannot use a GPU, it can do parallel processing with different cores. So you can have certain programs, they do allow you to add number of cores, and if you specify those, then it will use multiple CPU cores to parallelize the job and make the training go faster. Additionally, because there is no GPU, and so there is also no support for deep learning or reinforcement learning. And even though that's the case, there is a simple multi-layer perceptron that can be modeled, and we'll look at that. So using this particular module for deep learning, the packages would be TensorFlow, Keras, and PyTorch. So we'll be going through these in future videos, but for this series where we are focusing primarily on scikit-learn, We won't be talking much about deep learning or reinforcement learning aspects. That was it for this video. I hope in this video you got an overview of what is machine learning and what are the different terminologies in machine learning, what do they mean, and also getting an idea of what free computational resources that are available online, such as Google Colab. That's one. There are several others. I just mentioned one that I've been using. And finally, uh, what Scikit-learn can and cannot be used for. So it does not have a GPU support. So that's the one big point I wanted to mention here. I hope to see you all in the future videos. Please like, share, and subscribe. Thank you.